You see that? Yep. Okay. So yeah, the title of the class this morning is Introduction to Agroecology, an opportunity to feed more people on a crowded planet. Um, as a quick overview of the class, we're going to start by talking about some of the challenges to the food industry today. Agroecology is a movement obviously directed towards small farmers, people who live in rural areas who are engaged in providing their own food, growing food for their local communities, for the local market. Um, but the direction of the food industry today is almost completely opposite to that of what agroecology directs, right? And so we're going to talk a little about some of the challenges that our globalized industrial food system brings to the table. We're going to talk about the issue of growing population and the need to increase the amount of food that we produce in the coming years, the expansion of the agricultural frontier, and some of the environmental and health effects that we should expect if the status quo continues, if we continue to centralize this globalized food system that causes lots of problems, like we'll see. We're then going to talk about some of the proposed alternatives on the table. I think it's fairly well that these issues, growing population, expansion of agricultural frontier, and all of the gamma of environmental and health effects that this creates has led a lot of people to understand, from governments to nonprofits to development engineers, scientists, etc. Most people are in agreement that things need to change, that something needs to change, that we're simply not going to be able to maintain the way we're doing things right now. But the two of the main alternatives that are being pushed by many people in the development world, people with lots of money and influence, is further genetic modification of the agricultural crops that we're using. The other alternative on the table, and I've talked about this in other classes, is taking food production off the land through the expansion of lab-grown food, essentially making small farmers obsolete, saying that, there's a lot of problems with growing food, and so what we're going to do is we're going to, turn that extremely important, aspect of human livelihood over to scientists who are going to do it in a laboratory. So we're going to take a look at those two alternatives and see what we think about that. And then lastly, I want to obviously get into what is agroecology. Agroecology is another alternative on the table that is fundamentally different from more GMOs, more genetic modification of our food crops, and in a much different approach to providing a growing population with healthy food by small farmers instead of by people in lab coats, right? So we're going to talk about what is agroecology. We're going to discuss 10 of the principles of agroecology. There's a really good document that was put forth by the United Nations, the Food and Agriculture Organization, a couple of years ago that outlines very succinctly the 10 principles of agroecology. And I think that's a good starting point. And then lastly, we're going to look at the social aspect of agroecology, which is, for me, one of the fundamental differences between, say, organic farming or permaculture and agroecology. This idea that agroecology understands that growing food doesn't happen in this kind of vacuum. The process of growing food is intimately connected to all sorts of social indicators, issues of equality, access to land, all of these structural elements that will determine, how food is grown, how it's distributed, etc. All right, so let's start at the beginning. The overview of the challenges to the food industry today. This is a fairly common, I guess you could say, kind of picture or document explaining everything that's wrong with this model of industrialized, chemical-intensive, industrial, globalized, monoculture growing of food crops. This is what is growing around the world. We're going to say that there are still obviously an enormous amount of small farmers using traditional methods. But around the world in developed countries and underdeveloped countries, This is what is occurring, this idea of CAFOs, or concentrated animal food operations, for animal agriculture, the monocultures of soy, corn, wheat, rice, and other staple crops, thousands and thousands of acres grown using huge amounts of tractors and chemical inputs. This model of industrial agriculture is one of the main contributors to climate change around the world. There's different estimates, but some people say that the globalized industrial agricultural system might be responsible for up to 25 to 30% of all greenhouse gas emissions. This happens through nitrous oxide, carbon dioxide, and methane, all three of those. So nitrous oxide the majority of that comes from the production and the use of nitrogen fertilizers, which is, the global, this monoculture industrial system is absolutely dependent on artificial inputs, especially, artificial and chemical fertilizers. And these chemical fertilizers, when we spread them on the soil, a lot of them oxidize, and nitrous oxide, which is one of the most potent greenhouse gases. It's not necessarily the one that contributes to most global warming, but it is the most potent, the strongest greenhouse gas. Obviously, carbon dioxide, methane is another huge one from these concentrated animal feeding operations. And here's a little bit where it says there's about 170,000 kilotons of methane come from livestock. 85,900 kilotons of greenhouse gases come from manure management. This monoculture of rice cultivation, the energy used by these massive combines and tractors, the energy used to produce all of these chemical fertilizers and pesticides, the energy used to transport all of these food inputs from around the world, improper soil management, burning of crop residues, converting forest and other types of land to cropland. All of these are examples of how farms contribute to climate change, which is just one of the environmental effects we're going to look at. But this part right here, I don't know if you can read this right here. It says, agriculture can also be a land use sink, meaning that when properly designed and properly implemented, a diversified small-scale farm that increases soil fertility over the long term, that introduces tree crops and other perennial agricultural systems, can actually capture the excess amount of carbon dioxide in the air. So while the industrialized farming model certainly contributes to global warming by changing to a regenerative, to an agroecological model, the farms that we farm today can actually capture more carbon dioxide than what they create. So that's one issue. But here's something that we need to think about. Between now and 2050, in the next 25 years, more or less, we're going to explode as a global population to somewhere around 10 billion people. Hunger levels today are rising around the world, especially after the COVID pandemic. The amount of people who do not have sufficient amount of food is growing. As many as 828 million people, or about 10% of the world's population, go to bed hungry every night. 46 million more than the previous year. The amount is increasing. As our population grows, the amount of people who suffer from hunger are also rising. Due to climate change, agriculture yields of the major crops such as wheat, corn, rice, millet, some of these major soybeans, some of these major crops are also considered to decrease. There's climate instability, hotter temperatures, more severe weather patterns. All of this could lead to price spikes, food insecurity, social unrest, political tensions, conflict. We're already seeing this. Here in Central America, where I live, there's an enormous amount of migration to the United States, to Canada. And many people are leaving rural areas simply because there's longer periods of drought. Growing food is becoming increasingly hard due to the climatic conditions caused by global climate change. By the year 2050, this is from the United Nations, we will need to produce at least 50% more food than we currently do to feed the 10 billion people. This is the issue on the table. We know that our current globalized industrial food system is causing an enormous amount of problems. We also know that it's leaving millions of people, almost a billion people, suffering from starvation and hunger. At the same time, in the next 25 years, we actually have to increase the amount of food that we're growing. This is a conundrum. It's something that we have to think about. One of the issues is food waste. Because of this globalized nature of our food industry, almost 1/3 of the food is lost or wasted. So this 828 million people who are going hungry right now, it's not because there's not enough food being grown. It's because it is not being distributed correctly. There's all of these inequalities. There's waste happening on every level of the supply chain. The United Nations Sustainable Development Goal number 2 is to end hunger, achieve food security, improve nutrition, and promote sustainable agriculture. How we respond to this issue is going to be one of the most important elements of how we maintain a healthy society in the coming years. Um, at the same time, another issue that we're facing is that as we're faced with this need to increase the amount of food that we grow, what's happening is that we're expanding the agricultural frontier. Ever more and more parts of our earth are being transformed, not just into cities and to residential areas, but also into farmland. Over half of the land in the world is already used to produce some sort of food. And agriculture obviously has a significant negative impact on the environment, especially when it follows this monoculture industrial growth model. Um, we need innovations to produce enough food sustainably. Um, an example of the expansion of the agricultural frontier is here in South America, the Amazon rainforest, the biggest rainforest in the world, lost about 1.9 million hectares of forest in 2022, mostly to convert that land to soy production, cattle pasture, and other agricultural exploits. So one thing that we might face, one possibility is as we need to increase food production by 50% over the coming years, what might happen is we might end up ruining the last remnants of rainforest, of traditional pasture land, of traditional grasslands. I mean, that is an opportunity on the table that we can continue to convert ever more and more of Earth's ecosystems into these monoculture industrial food farms. Another problem that we're facing with the industrial food model that is becoming increasingly globalized and homogenized is that it is entirely dependent on an enormous amount of pesticides, and this causes all sorts of environmental effects. There are over 1 billion pounds of pesticides used in the United States each year, and about 5.6 billion pounds used worldwide. In many developing countries, there's essentially zero regulation on what types of pesticides can be used. So, for example, here in El Salvador, where I live, and I would imagine it's similar in many African countries, a lot of the strongest and most dangerous pesticides and other chemical inputs that are banned in the United States, in Canada, and Europe are sent here, and they're sold freely. A 10-year-old kid can go to the agro store and buy these extremely strong poisons. Pesticides use per area of cropland is about 2.26 kilograms per hectare, and that continues to increase year after year. Obviously, the pesticides and herbicides that we're using disrupt this delicate balance of soil microorganisms that are responsible for nutrient cycling. When you have a farm model like what we see here in this picture, the soil is being transformed from this live, extremely complex and diverse ecosystem into essentially a growing medium. Industrial agriculture is a form of mining. It's mining the soil for the little bit of fertility that's left. And what you get is, because the soil is essentially bereft of any sort of nutrients, of all of these diverse interactions between earthworms and bacteria, nematodes, et cetera, what you get is that the crops that are grown are essentially nutrient empty, right? They're all of the micronutrients, all of the vitamins and minerals. So, for example, if you're going to grow a carrot, if you grow a carrot in a really, deep, dark, fertile soil, that's going to have an enormous amount of vitamins and nutrients. Today, what you get is you might get this massive carrot that's 50 centimeters long and super thick, but it's essentially empty of any sort of nutrients. You can taste that, obviously, in the taste. But so what we get is we have people who are eating foodstuffs that are essentially empty. It's empty carbohydrates, empty nutrients that really aren't what we need. The result of this globalized food system that we have today is that more and more people are suffering from obesity. Strangely enough, despite the fact that we have, almost 1 billion people who are suffering from hunger, there's about 38% of the world population, almost 3 billion people, are overweight or obese. And that's not just in rich countries. One of the things that the UN says is that obesity is increasingly a sign of poverty because people who are poor cannot access healthy foods. That more and more people are the only things that people can purchase, especially people in urban areas, are these super processed, ultra processed foods that are nutrient empty, high in empty carbohydrates. And expected that almost more than half of the world's population in the next 10 to 12 years is going to be suffering from obesity. Um, so yeah, what we have today with this industrial agricultural model is a model that is contributing to global climate change, a model that is leading to more and more hunger, while at the same time leading to enormous amounts of obesity, that is chopping down ever more parts of our rainforest and converting the remaining parts of untouched nature into cropland, and essentially poisoning the earth and poisoning our bodies. Um, like I said, most people are in agreement that something needs to change, that we can't continue this. If we grow our population another 2 billion people in the next couple decades, we have to find a different way to feed the earth, right? And so the people who are in charge, politicians, scientists, a lot of these major agro corporations have been very active in putting solutions on the table, saying this is what we need to do. This is how we're going to respond to this very, very serious and critical issue. And one of the things that's put on the table is what you see in this picture. We need more scientific innovation, which means more genetic modification of crops. Um, the Bill Gates Foundation is extremely uh, involved in promoting a type of agriculture that he thinks, or that his foundation thinks, will respond to the crises that industrial agriculture is facing. The Gates Foundation has a flagship agricultural program in Africa called the Alliance for a Green Revolution in Africa. This program has billions of dollars of funding, and it works to try and actively transition small farmers away from traditional seeds, traditional crops, traditional forms of growing, and tries to encourage these small farmers to use patented seed, fossil fuel-based fertilizer, other inputs to grow commodity crops for the global market. The foundation says its goal is to, and this is a quote, to boost the yields and incomes of millions of small farmers in Africa so that they can lift themselves and their families out of hunger and poverty. The strategy is modeled on what happened in the Indian subcontinent, that certainly boosted production of staple crops, but also left a legacy of structural inequity and escalating debt for farmers that contributed to the massive mobilizations of peasant farmers. There was a report that came out about a year ago that was trying to look at what were the effects of these billions of dollars of funding that were being funneled into Africa through the Alliance for a Green Revolution in Africa. And what they found was that in the 13 focus countries where this program was being developed, 30%, the incentives from this program drove into GMO corn mostly, and out of more traditional crops, eroding food security and nutrition for poor farmers. So essentially, the number of undernourished people in these countries increased by 30%, while the stated objective was to do exactly the opposite, which I think shows that this focus on increasing the amount of dependence on chemical inputs, on chemical fertilizers, on patented seeds, on GMOs, on genetically modified organisms is a strategy that has been shown to fail. At the same time, it continues to happen. Not only the Bill Gates Foundation, but there's all of the major agrochemical corporations are doubling down on this idea that we need further genetic modification of our food crops. It's estimated today that up to 80% of processed foods contain some sort of genetically modified organization. Corn and soy constitute the bulk of the feed consumed by cattle, hogs, and poultry, while alfalfa is a major component of feed for dairy cows. In other words, most of the animal products you eat and almost all of the processed foods that we eat depend on GMOs. Today, there's all this new research into how we continue to use GM organisms. For example, creating crops with improved resistance against plant disease, crops with increased nutrient levels, fish species with enhanced growth characteristics, the production of more nutrient staple plants that provide the key micronutrients that are lacking. Essentially, this is trying to say what we need, what many scientists and agro corporations are saying is we need more human control, scientific invention, and certainly more corporate control over food. One of the things that I find extremely interesting is that they're saying that this last sentence right here is saying that it's a recognition that the monocultures of industrial agriculture create food crops that are essentially nutrient empty. Instead of returning to a more sane way of growing foods on a small scale, diversified, using traditional crops, traditional seeds, organic growing methods, they're saying, no, we can use genetic modification to put back in these nutrients that our model has already ruined. This is one thing that's on the table. You can see that there's an enormous amount of corporate control over this model of increased GMO crops. 70% of the seed and agrochemical industry is in the hands of three merged companies. These companies were already Dow DuPont, Syngenta, and Bayer Monsanto. Bayer Monsanto used to be a separate company. They've come together. Dow DuPont used to be separate companies. They come together. But there's this kind of global hegemony control over something as vital and basic as foods. Bayern and Corteva, which used to be DuPont, now own extensive patent portfolios on all of these new GMO techniques. These corporations are moving to patent plant genetic information that can occur both naturally and a part of their modification, claiming that the plants that have those genetic traits are their invention, their property. As this continues, if we want to plant corn, a lot of times they're going to say that corn seed is theirs, and then we have to pay them for that. This is a stealing, a theft of traditional knowledge, of all of the thousands and thousands of years of small farmers around the world developing their own seeds, and now these major corporations are essentially extracting this knowledge, privatizing it, and profiting from it. You can see that they continue to apply for patents. Last year, Corteva applied for over 1,400 new patents on their GMOs. So this is one method. This is one response to the problems. We need more corporate control, more GMOs, more chemicals. We can talk about if that's a good idea or not, but that's certainly something that's on the table. And then lastly, the other thing that's on the table, this is kind of a new strategy or a new proposal, is to say, we know that farming causes all of these environmental problems. It takes over, it's responsible for cutting down rainforest, it's causing greenhouse gas emissions, et cetera, et cetera, et cetera. And so one of the solutions on the table is say, well, let's take farming off the land, right? Let's essentially exterminate or extinguish farming as an occupation. And let's put food production into laboratories, into the hands of scientists. And there's billions and billions of dollars being poured into everything from plant-based meat to cell-based meat to using a technique called precision fermentation, where they essentially, scientists take some molecules and put these into these massive vats that you see here, and then use those vats to ferment and essentially multiply these molecules into things that resemble what we know as food. I would say that is probably one of the most insane policies that can be there. This idea of something as essential as food, which we all need to eat 2 or 3 times a day, and essentially eliminating this process of learning how to grow food from the land using the free inputs of sun, of wind, of rain, of managing the soil fertility. This wisdom that has come from small farmers over the years is saying, well, we're just going to throw that out the window, and we're going to turn over something as fundamental as food production to certain technologies that haven't been proven. And one of the things that there's a really great report that criticizes this idea of transitioning to a lab-grown food model, and is written by this guy named Chris Smage, and he wrote an entire book criticizing this. And he says that one of the biggest problems is that lab-grown food requires energy, requires electricity inputs. And at a time, he says, this is a quote from his book, when we desperately need to decarbonize the global energy system, and we're largely failing to do so, manufactured lab-grown food proponents are suggesting that we simply stop using the free, zero-carbon source of energy, the sun, to provide our dietary protein and use costly generated electricity instead. We need to use the world's entire current solar energy consumption more than twice over just to produce sufficient protein globally when it's sorely needed for other things. He says, I believe that this technology is a clear non-starter and as a mass food source. So, I mean, really, when you think, the corn that we grow, the beans that we grow, the apples, the fruit, all of these things use the free energy of the sun. Plants have obviously the ability to photosynthesize, to take the light from the sun, turn it into sugars and other complex carbohydrates, and it's the beginning of all of the food chain, of all of life on Earth. And we are seriously thinking of that human ingenuity, that science, that engineers, that technology can replace that, requiring an enormous input of energy. This is also on the table. It's happening. Like I said, there's billions of dollars being poured into this type of research. I'm going to argue that both of these proposals, increased GMOs and a transition to lab-grown food, are extremely dangerous, are extremely naive, would put us into a situation of increased vulnerability. As our population grows to 10 billion people, we do need to grow more food. But agroecology states that we can do this by trusting the tried and true techniques, traditional growing techniques of small farmers. And we can increase that knowledge, and we can add to those traditional forms of knowledge through scientific inquiry, through discovering new ways to use traditional growing methods to add some different ideas. So agroecology is kind of this mixture of traditional farming knowledge that's held by small farmers, by indigenous people, by peasants around the world, and adding the scientists who are looking about how we can increase this form of decentralized, small scale, diversified production in a way using natural fertilizers, using crop rotations, using all of these different perennial agroforestry systems, doing everything we can to increase the amount of production on small farms, while also turning agriculture into a sink for carbon dioxide. So instead of emitting all of these greenhouse gas emissions, a healthy, diversified farm ecosystem can provide an enormous amount of food, provide an enormous amount of jobs, obviously, for people who live in rural areas, while also generating a positive environmental impact. So what are some of the benefits of agroecology? Well, when you're growing food in an organic and a natural way, it's going to boost nutrition and health instead of eating, these highly processed foods that are essentially empty and devoid of all nutrients. People will have access to different, healthier foodstuffs. Another benefit is that it integrates different types of knowledge, right? Whereas, this GMO model or this lab-grown food model is completely dependent on this scientific paradigm, right? Experts who work in the laboratory are the ones who are going to take over this this production of food. Agroecology says, no, we need the wisdom and the knowledge of small farmers, of peasants, of indigenous people, and we can combine that with the studies of scientists and engineers, et cetera, right? So it's a way of integrating different types of knowledge. Agroecology, when done correctly, preserves natural resources and biodiversity. Instead of consuming the soil, instead of poisoning the earth with all of these chemical pesticides and other inputs, agroecology seeks to preserve the soil, to enrich the soil, to increase forest cover through agroforestry models, etc. It seeks to produce more with fewer resources and fewer inputs. There's this idea that when you institute, when you set up, when you design an agricultural system in a correct way, in a regenerative way, you can increase the amount of food that you produce without having to rely on chemical fertilizers that are created using an enormous amount of energy and synthetic inputs. And lastly, this is extremely important, I think, for especially for people who work in in community development in rural areas, is that agroecology can enhance the resilience of rural people. We've talked about in other classes that I've led about this tendency for rural people to abandon the countryside and move into cities, the increasing urbanization of our world, and by shifting our agricultural paradigm away from this centralization, this industrial model, more small-scale farmers producing more for local markets has the ability to create an enormous amount of resilience, of economic opportunity for rural communities. So what is agroecology? Let's look at some definitions. Agroecology is a holistic approach to growing food that seeks to reconcile agriculture and local communities with natural processes for the common benefit of nature and livelihoods. This definition in itself is essentially the exact opposite of what industrial agriculture is. Industrial agriculture is not holistic; it's very focused. It doesn't seek to. Industrial agriculture essentially ruins local communities by advocating for larger and larger farms, mostly that are owned by these corporate entities. And obviously, industrial agriculture has nothing to do with natural processes. It's about imposing, this human paradigm of control through pesticides, through chemical fertilizers, through GMOs, etc. Agroecology also uses different sciences, the science of ecology, the science of social science, the different social sciences like sociology, agricultural science, soil science, to understand the elements of ecosystems, such as soil properties, plant and insect interactions, social sciences to understand the effects of farming practices on rural communities, economic constraints to developing new production methods, cultural factors to determining farming practices. Agroecology understands that the process of growing food isn't just a technical one. It requires a wider view of all of these structural impediments, all of these cultural aspects, et cetera, and try and integrate all of this into one kind of determined strategy. Empirical and scientific evidence shows that small farmers around the world, especially those who grow food on 2 hectares or under, are the ones who feed the world. According to the Food and Agriculture Organization of the United Nations, 70% of food we consume globally comes from small farmers. This is for me, one of the most important statistics to look at, that this debunks some of the myths that large-scale farmers, large-scale industrial farms are needed. No, what we need is to potentiate, is to encourage, is to find ways to help small farmers increase their production, stay on their lands, and combine traditional knowledge with some of the scientific input that agroecology can offer. Agroecology is thus a combination of scientific knowledge and traditional farming wisdom that seeks ways to boost the productive capacities of small farmers while also looking at all of the structural injustices that affect the farming practices of small farmers. There's a really, really great document that came out about 3 years ago by the United Nations that outlined the 10 principles of agroecology. And I think this is a really good starting point to try and understand what agroecology is all about and how it is so different from, for example, the GMO and the industrial model that's being pushed by the Gates Foundation, by all of these major agro corporations. So this is a picture you can come back and look at. It shows, it explains what these 10 principles are and how they're all interrelated. But I'm going to real quick just kind of talk about all 10 of those. So yeah, firstly, it's diversity. Diversification is a key component to any sort of agroecological transition in order to ensure food security and nutrition while conserving, protecting, and enhancing natural resources. Like I said earlier, this monoculture industrial model is focused on growing one crop. Growing one crop obviously requires an enormous amount of pesticide use, and it depends on this globalized market where foodstuffs are shipped around the world. Diversity, growing an enormous amount of crops on one space is the key to both ecological health and I would say economic resilience, right? So a small farmer, if one of your crops fails because you didn't get good rains, that doesn't mean you're going to be broke. It means you have other crops to fall back onto, right? It's about not putting all of your eggs into one basket. Another principle of agroecology is the co-creation of knowledge. Agricultural innovations respond better to local challenges when they are co-created through participatory processes. Again, going back to this Gates initiative, the Gates Foundation is saying, look, small farmers, abandon your traditional knowledge, take these seeds, take this pesticides, take these fertilizers, and grow them the way that our technicians tell you how to. Agroecology is not about that. It's about saying, let's start with what works, what small communities are doing around the world. And then maybe, scientific discovery and innovation can add some things to this traditional knowledge. It's a co-creation, a process of creating knowledge and approaches to growing food together. Um, Synergies. Agroecology is also about building synergies or connections, enhancing key functions across food systems, supporting production and multiple ecosystem services. So, for example, a lot of people say that agriculture, one of the problems with animal agriculture is that we knock down all of these forests to turn forests into grassland, into pasture. One synergy might be taking this grassland and creating a silvopasture system or a agroforestry system. So planting fruit and nut trees and timber trees on pasture land where grasses are still going to grow, where farmers can still, take their cattle and their sheep and their goats to forage. But then also have a secondary crop. So then you have this synergy between all of the ecosystem services that forests provide, while also allowing traditional farmers to maintain the practice of raising animals for food, for milk, for market, for fertilizer, for all of those different things. Efficiency. Agroecology is about innovating agroecological practices to produce more using less external resources. So, for example, like we mentioned, nitrogen fertilizers, synthetic nitrogen fertilizers are the backbone of this kind of green revolution model. But it's extremely inefficient because there's studies that show that about 50% of the synthetic fertilizers that people use on their farms are essentially wasted. They get washed away into rivers, leading to all of these dead zones in rivers and in oceans, and essentially an enormous amount of wasted. By focusing on using nitrogen fixing crops, intercropping, for example, corn with beans, intercropping certain crops with nitrogen fixing trees. This is a way that we can make more efficient this process of giving plants the nitrogen they need in order to grow. Another one is recycling. More recycling means agricultural production with lower economic and environmental costs, right? The more that we recycle, for example, turning last year's crops into compost in order to enrich soil fertility. This only, this reduces the burning. A lot of people burn, their refuse from agriculture, leading to further carbon emissions, leading to poor air quality. And then people then have to purchase additional types of fertilizer. So by recycling all of these organic inputs from the farm, this creates economic and environmental benefit. Real quick, resilience. Diversified agricultural systems are also more resilient. They have a greater capacity to recover from disturbances such as drought, floods, and hurricanes. Human and social values. Agroecology can protect and improve rural livelihoods, rural equity, and social well-being. by culture and food traditions, by supporting healthy, diversified, and culturally appropriate diets. Agroecology contributes to food security and nutrition while maintaining the health of ecosystems. This is important because, again, this GMO model says to the small farmer, quit growing your traditional crops, the crops that your ancestors grew, the crops that are important to you culturally and socially, and grow this monoculture of crop that you can then sell to the market. You won't be able to eat it, but you have to sell it, and then you can use that money to purchase generally unhealthy foods that you buy at the store, at the supermarket, etc. Agroecology is about maintaining, this wealth and wisdom that comes from traditional food traditions. The last two are responsible governance. Sustainable food and agriculture requires responsible and effective governance mechanisms at different scales, right? You need to have this governance model that includes everybody and that increases participation. And lastly, circular and solidarity economy. Agroecology seeks to reconnect producers and consumers to try and get rid of these middlemen, right? That take over so much of the money that agriculture produces. And that prioritizes local markets and local economic development. This is something that's extremely important, again, because the agro-industrial model is all focused on exports, on globalized food systems, whereas agroecology is without a doubt focused on small scale, localized economies. And then lastly, like I mentioned, one of the major differences between agroecology and other types of, let's say, organic farming or permaculture is that agroecology has a very strong focus on some of the social and structural elements that affect how we farm. So, for example, just one is the whole issue of land access and land reform. Small farmers today are feeding the world with less than a quarter of all farmland in their possession, right? The majority of farmland today is being monopolized by these big corporations, by large-scale farmers. In Africa, there's all of these studies about China and India and other countries buying up huge swaths of land to try and secure, their future food security, but at the peril of small scale farmers in Africa. Here in Latin America, it's the same issue where people have increasingly smaller plots of land and are trying to grow enough food to feed their families and for the local market. So here's six things I want to end with. The vast majority of farms in the world today are getting smaller and smaller as more and more of these big corporations buy up land. Small farms are currently squeezed onto less than a quarter of the world's farmland. We are fast losing farms and farmers in many places, while big farms are getting bigger. Small farms continue to be the major food producers in the world. Small farms are overall more productive than big farms, right? So, and lastly, it's important to say that most small farmers are women. This is something I think is also important, this gender kind of consideration. So I would say that if we take these six issues that are fairly well established, I would say that this industrial agricultural model, which focuses on all of these environmental and social and health problems, and it's being proven that is not the best way to produce food. By helping small farmers to gain access to more land, to gain access to local markets, to increase the production with some scientific inputs that at the same time rescue and value traditional knowledge. Agroecology is a pathway for how we can respond to increasing food production by the year 2050 for our growing population. Real quick, I think it's about 8:50 almost my time. So we have about 10 or 15 minutes where I would love to open up the floor for you all. I'm going to